All right, in step two, we'll talk about establishing a connection. So, the most common connection that we'll talk about is a TCP connection. There are other types, but for there to be a connection between a client and a server, there usually has to be this thing called a TCP handshake, um, and it's called that because it's sort of like this process here, where the client sticks out their hand, the server also extends their hand, and then they connect with each other and they agree upon how they're going to communicate with each other. And if this handshake process isn't completed, then they can't talk with each other. So to look at the handshake process in Wireshark, we're going to add the following filter: ip.adder equals 192.168.164. So type this in here in the filter: ip.adder equals 192.168. I'm going to forget the rest. 0.1.64. Oh, I have an extra dot in there. Goodbye. There it is. All right, once I have that in, I'm going to hit enter. And that's going to filter the traffic to just be packets that have a source or a destination of 192.168.1.64. So most of the packets are still here, just not all of them. So next we're going to look for some packets that have these words in it, either SYN, ACK, or SYN, ACK. And those are the three parts of the handshake that we're trying to find. So I have a bunch of ACKs here. I'm going to scroll down. I'm looking for SYN. No SYNs yet. Oh, here's one. So packet 78, that's a SYN. That's the first part of a TCP handshake. Then the SYN ACK is packet 83. Okay, so that's a response from the server. You can see that it goes client to server, then server back to client, and then there should be one more that goes back from the same client to the server, which is packet 84, and that's the ACK. So we've got the SYN, the SYN-ACK, and then the ACK. And altogether, the SYN is the client sending out, extending their hand. SYN-ACK is the web server also extending out their hand, and the ACK is the two hands grasping each other. So after those three packets have been exchanged, we have a valid connection. So to figure out how long this process took, the original SYN SYN packet was sent on August 27th, 2013 at 17:08, so 1700 hours, 8 minutes, and 38 seconds. And then the acknowledgement for that was 17 hours, same day, 17 hours, 8 minutes, 38 seconds. Is it the same to the second? Yeah, it's same to the second. The difference is the milliseconds. So this one's at 0.024 and this one's at 0.107. So that's a difference of, let's see if I can do math, about 0.9, yeah, 0.9, what would that be? 0.98. About 0.98 seconds. So about a second it took for a handshake to be established. So not too long. All right, so that's for a regular TCP handshake. Now we can also look for a secure TCP handshake as well. To do that, we're going to first switch our filter from being IP-adder equals to IP-SRC equals. And so that means we're only going to see packets who have a source of 192.168.164. And I'm going to go to the top. And this time what we're going to look for are packets that have to do with TLS. TLS stands for Transport Layer Security, so this allows us to have a secure TCP connection. So I'm going to look to see if I can find TLS, see if it's in here anywhere. Oh, here's one. So that's the one that I want to find. It's packet 85. And what we're going to investigate on packet 85 is we're going to go into the details. So that's in here. I'm going to close this down. And I'm going to look in the secure socket layer section under the TLS section and under the handshake protocol client hello. And you can see there's just a ton of information here. You're like, what is all this? In short, this is information for encrypting the communication between the client and the server. So it allows both endpoints, the client and the web server, to agree upon an encryption scheme. So that way the information sent over the internet could not be eavesdropped on very easily. All right, and that's the end of step 2.